Sorry. So it's highest in the middle, goes off in the same direction. In a perfect world, if I had drawn it right, it would be completely symmetrical, and it is completely symmetrical around the mean. And since this is a sample mean, or population mean, what is the symbol that they use for mean? Anybody remember? Yeah, mu for the population mean, right? Okay, so that little symbol, it even looks like a funny M, right? So there. Then we have standard deviations going off to either side. How many standard deviations on either side? Do you remember? Three on either side, on each side, right? Good. Okay. So, and as you move across, then you have different percentages. Now, we're not interested in memorizing the percentages because all of the ones that you had on your exam that I saw all required that you use a z-score, meaning that your data didn't fall exactly on one standard deviation or another. But if it does, then you can still use the same piece of information, right? So you can use the same information. So there's a couple of things that we want to talk about. The most important thing that you can do when you're looking at these is to get your shading right. If you get that shading right, then the rest of it's just a matter of reading information from the chart, right? So you always want to shade simply the area you are looking for. It's really that simple. Don't make it harder than it has to be. So if I'm looking for 2 standard deviations above the mean, above the mean means that I'm going to be to the right or the left of that center line. What do you think? To the right, yeah? We're going above the mean. So on this side is above the mean. On this side, you're below the mean, right? Makes perfect sense, yeah? And again, who cares? Don't remember the 34.7% or whatever. It doesn't make any difference. You're going to use the chart for finding all of these, so don't memorize all those percentages. Now, 2 standard deviations above the mean. So if this is 1, that's 2, that's 3, right? So I'm talking about everything that's bigger than that line. Do you agree? So that whole area, that whole tail, including the stuff, it's everything above that. Real rocket science, right? The only times it gets troublesome is when you have the between situations, okay? So say you have between 1 and 2 below the mean. So we have between 1 and 2, and by that I mean 1 and 2, I mean standard deviations, okay? Between 1 and 2 standard deviations below the mean. So that means you've got a definite starting point and a definite what? Ending point. Is it above or below the mean? Below the mean, so that means we're talking about to the left. So if that's 1, that's 2, that's 3. So between 1 and 2 would simply be that area there. Right? If you know the area you're looking for, then it makes your life much easier. Because when you're reading the information from the chart only gives you information in that direction. Which means you can infer for the same information from this other side because they're a mirror image, right? The problem happens when you want something like this. Here, I want just this little tail, okay? But the chart is going to give me a lot more information than I need. So I'm going to have to subtract out all of this area. See, the part that I don't need. Okay, so what we're going to do is we're going to look at a couple of the questions from your test and see if we can work on those. But let's first talk about the formula for z-score, which you do not have to memorize. Why? Yeah. Well, you're given the formula for the z-score as well. But if you don't know what all those pieces mean, then you're going to be in trouble. A z-score just tells you a number that you can read off the chart, because you're given the chart of all the z-scores. So in other words, somebody's done all the math for you and put it on a chart. But you need to know these pieces. So your x is the value that they give you. So they're going to give you some value. We already know what mu stands for. Mu is simply the what? Mean. The mean. They have to give you the mean. And sigma, that little O with a tail on it, is your standard deviation. Excellent. And you need all of these pieces in order to be able to, right? So that's your data point, kind of, your value or your data point. You need all the three of these pieces of information in order to be able to calculate a z-score. Then once you've calculated the z-score, again, very easy, simple mathematics, then all you're going to do is just read the information from a chart. But you're going to make sure that you're reading the information from the chart and then use your shading to get your actual answer. So it's a two-step process, okay? All right, so let's just calculate a z-score looking at your exam. Sorry, didn't have it in the right spot. Okay, here we go. So question 1. Mandy is a gymnast who often has to see Jane, the physio, to treat her injuries. The time that patients have to wait to see Jane in the waiting room is normally distributed with a mean of 20 minutes and a standard deviation of 6 minutes. What is the probability that she has to wait between 15 and 20 minutes to see Jane? Okay, so the first step. Oops, sorry. Let me get the annotation. Too many buttons. All right. Your first step is to draw your curve. Always start by drawing your curve. All right. Second step. Label the mean and the standard deviations. And when you're talking about labeling these, I want you to use the numbers that they give you, because they're going to give you a mean and the standard deviations, and you can put actual number values for those. Because like in this particular instance, we're going to be looking at exactly one standard deviation below the mean. So we don't even have to calculate a z-score for that. So once you've labeled them, so let's just draw our normal curve, and I know it's already drawn there for you. They gave us a mean of 20, and then they say each standard deviation is standard deviation of 6 minutes. So that means as I go to the right, we're going to be adding 6 minutes. So 26, 32, 38. See where those numbers came from? And as we go below the mean, we're going to be subtracting 6. So 14, 8, 2. If I subtracted 6 correctly? Okay, good. You never know. All right. So now we know what below the mean and above the mean looks like. Okay. And we're talking about, let's see, what is the probability that she has to wait between 15 and 20 minutes to see Jane for treatment? So if you know where the numbers are, then you know what area you're going to be looking for. So are we talking about an area above the mean or below the mean? Below the mean, right? So 15 to 20 minutes. So we're talking about an area that's in there, right? So that boundary is 15 minutes. Does that fall directly on a standard deviation? No. So if it doesn't fall directly on a standard deviation, we have to calculate a z-score. All right? Now notice that our shading touches the mean. Do you notice that? That's a good thing. That means that we can read straight from the chart. Doesn't matter that it's on the other side, but if it touches the mean, then you can read right from the chart. And I'll show you, and I'll tell you what I mean by that in just a second. So we're looking for the probability that it's between 15 and 20 minutes. And so we need to first find our z-score. So our data point, our boundary from the mean is 15 minus our mean of 20. What's our standard deviation?
6.
Okay. So if we put those in, what are we going to get? So what we're doing is we're calculating the area based on this particular point. So that's going to give us -5/6, which we can change to a decimal, which is negative what? Anybody? I don't have a calculator with me. We're only worried about 4 decimal places because that's as far as our chart goes. Okay? And it would just be another 3, so that wouldn't round that up. Right? So calculate your z-score. Here's our z-score. Do I care that it's negative? No, because there are no negative numbers on my chart. The reason it's negative is because it is what? Below the mean. So that doesn't matter. That just tells me that I got my shading in that I know that I did my math right. Yeah? That I put the numbers in the right order. So all I need to do is then go to my chart and then read that number. And that is the part that seems to be making you all crash and burn when this was graded, is reading the value from the chart. So it's not as difficult. So you go to 0.8, then you get to your first 3, and that gives you the first part of it. So make a note of that one, write that one down. And then over in the differences, you've still got more pieces of it. So continue over there until you get to the 3 again.
You go down to the 0.8.
And you go down to that same line. So we have another 3, right? We're still on that same line. Just keep going across until we get to the next 3. And that's going to give us another little piece of it.
And then you just add that on to the very last.
Okay? So it's finding it in 2 pieces. Our chart's always found it in 1.
And the 8 is technically 0.0008. So it's like it's in the
Yes. Read up to the tenths. Tenths being the first 2 digits, right? Second, find the one in the hundredths. Hundredths meaning the second digit after the decimal. And third, find the thousandths, which is this third decimal. Okay? When you find that one, that first intersection, you're going to get a value. When you find the second one, you're going to get a value. And you're simply going to take these 2 values and add them together.
So do we?
So reading down to the 8 and across to the first 3, you get 0.2967. Okay? But now we're going to go across, still going across the top, we're going to get the rest of it by getting to the 3 again. So where the 0.8 hits the 3 on the top there, which has an 8 in that column, right? But it's 4 decimal places, so it's 0.008. Okay? Just make sure that once you have the top number, the bottom number needs to line up to it. So you don't have to worry about how many decimal places it is. They're going to line up. Okay? Now what do I get when I add those together? Somebody?
297.
Okay. So you're just going to get it in 2 stages. We'll practice this several. We'll just make this our thing to do today until everybody understands it. Because it's very easy once you do it. It's just very odd that you have to do it in 2 stages. So let's make sure. And there we go. And they rounded it to 4 decimal places. So they got the same answer we did. Okay. So do you see where the answer is there to 4 decimal places? They use the calculator instead of reading the chart. And that's why theirs is so precise. They have so many more decimal places, but we don't have to. Yes, maybe. There you go. So let's just look at, everybody's have your chart in front of you. I'm just going to make up some z-scores, and we're just going to learn how to read the chart. Okay? Because I still think it's easier than the calculator, but of course that's up to you. If you want to learn the calculator, go ahead. Let's say that I have a z-score of, remember these are always going to be 3 digits, so 0.957. Okay, so that's our z-score. It's broken down into 3 parts. This first number, second number, and third number, right? This one is the one you read from that column under Z. So 0.9. Right? So just follow down to 0.9. Then we're going to go across from 0.9. And in this case, our second number is 5. So we're going to that intersection right there. Right? So 0.9, go across to 5, and you get it 0.3289. And that's the first value. But we still have to do this 7. So we just continue along the line all the way around 0.9, go across until we, in that differences column, until we get to the 7, and it gives us the number 18.
So 0.0018.
Exactly. They're going to always line up. So you never have to worry about what the number is, about where the decimal places are, how many decimal places. They're always going to line up. Okay?
Then do you plus that together?
And now we're going to add it together. And what do we get?
0107.
Sorry?
0107.
I got 0.33.
I'll be careful. Yeah, because there's something missing there. And so 0. Point what now? 307. There we go. And so is there. That is our area, our probability. Okay? All right. It's just a matter of learning how to read the chart. Let's just do one more. Let's just. No, that's not what z equals. That's the area. That's the probability. The area under that, which is the same as your probability. All right, now. What if you have a z-score, let's see, of 3.44? Right? Going down, you already have the 3 in the 3.4 part, right? Okay, we're going to have 3 decimal places, so let's just stick a 5 at the end. The 3.4, go to 3.4, then go across to what column? 4. So 3.4, go across to the 4, which is 0.4997. Right? So we've used that 4. But now we have to keep going across till we find the 5. But what is that number? So do we care?
No.
Nope. So there's our answer. Because what we're adding is some zeros. is good?
Yeah.
Right? Do you think you can read the chart now? And once you read the chart, then you've got your probability. As long as you're touching the mean. But if you move away from the mean, that means you're going to have to subtract out some areas. So you have to be careful about that. So look at the second one. What percentage have to wait more than 25 minutes for their appointment? Okay. So look at where the shading is this time. The shading is here just on this little tail. But our chart will only give us information all the way from there. Yeah? So what we're going to have to do is we're going to have to find two areas. Okay? Or find the area above that mean. So let's see. Hold on a minute. So that gives us a z-score. It's going to give us the area above the mean. So this is fine because we're not below on this side. So 20 minus, so we get 25. I'm not in annotation mode. 25 minus is our value, minus our mean, divided by our standard deviation of 6, which gives us 5 over 6, which we just divided out a while ago, and got a z-score of 0.833. Right? So we're going to read that information. From your chart. Reading first the 0.8, then the 3, then the 3. So 0.8 going across 3 gives you 0.297. 7, sorry. Right? And then continue over to the next 3, which gives you an 8, which we know is going to line up there, which gave us a total of 2975. Okay. Now, notice though that it's not what we have here, because our score gives us everything above that line. Okay? So we have to compensate for that bit that we're not going to use. Okay? So,
Thank you.
mm-hmm. So we found this. So what we want is this area, right? But we've found this area, the part that touches the mean. Is that the part we want, though? No. So, but remember that if you know the mean, all of the stuff on one side of the mean is how much? 50%, 0.5 of it. So all we have to do is subtract out what we don't know, what we don't need. So if the whole thing is 50%, why am I not writing? My pencil must be dead again. Yeah, my pencil is dead again. Hold on a second. So we can simply subtract out what we don't want from what we have, because it's bigger than that. So it's 9.9999% of the information. So what we're going to do is we're going to just subtract that out from 0.5 minus the part we found, and whatever's left will be that long tail.
So 0.5 minus 0.297.
And when you do that, what do you end up with?
2.
Sorry, I can't do it because my pencil's dead. Here we go. It should be okay now. So 0.5 minus 0.2975.
0.2025.
What is it now?
2025.
2025?
Yeah.
Okay. Now again, slightly different from theirs. Why? They did it using the calculator? because in reality, these things have lots more decimal places than just what we could read from the chart, but what you read from the chart is fine. So you see that when you do the read from the chart, it gives you everything from the mean on. But that's not always what you want. We only wanted that little bit. So if that whole part is 50%, and we have that part of it missing, we need to take that piece out because it's not part of our shading. Does that make sense? Okay. What if I had shading on two different sides? So let's say that I had my mean and I was looking for all of this area. When I read the information from the chart, is it going to give me all of that area? Nope. It's going to give me this, and then I'm going to have to find that. Now, if they're exactly the same, all I have to do is double it. But if it's different, that means I need a z-score for each one, each side. Okay? So let's go back to the test just to look at what else they gave us. So more than 25 minutes, so that gave us that gap. We had to find the area, then subtract it from 50%. So here's one. After how many minutes will 80% of Jane's patients have begun their treatment? Now, this time, they're giving you 80%, so do they tell you how long they wait? No. They're giving you a percent, which is the probability that they're going to wait that long. So from that, you're going to start inside the chart and then find the z-score that fits and work backwards. Pardon? Yeah. So first of all, we know that the area we're looking at is 0.8, right? 80%? Okay. So what we're going to do is look inside the chart and find the closest number to that. Okay? But that's okay because we already know this bit, don't we? 50. So let's subtract that out because I already know it. I don't care. So what's that going to give us? 0.3. Now, find 0.3. The closest thing you can find to 0.3 on your chart
Is 2.9 and 3.30.
It's in between the two, so you have to just find the one that's the very, very closest. So which one did you say was closest there? 0.3.